All right, so information density, it's one of the things, right? You
Yeah.
hear it and you think you kind of get it, like, okay, stuff packed together.
Right.
But it's way more interesting than that. We're going to do like a deep dive
Yeah.
into information density today. And for starters, think about like a rock,
Okay.
just a plain simple rock, and then like a glass of water.
Okay.
They both like have density, right?
Yeah.
In the normal sense. But which one feels, I don't know, more complex, more like capable of change?
That's a really good point. And it kind of highlights how we get tricked, I think.
Yeah.
By thinking that just regular density and this idea of information density are the same thing.
Yeah.
So density, that's just how much mass is like crammed into a space. Like,
Right.
your
Oh.
classic mass per volume.
Yeah.
But information density, that's a bit more slippery.
Okay.
It is about how much information is packed in, but like you were getting at, it's also about how well organized that information is, like how usable it is.
So a rock, like it might be dense, you pick it up, it's heavy,
Yeah.
but it doesn't automatically mean it's like bursting with useful information.
Exactly. It's like, think about the atoms in a stone, right? They're stuck
Yeah.
in this like rigid, unchanging structure. It's like, I don't know, like a library where all the books are like chained to the shelves.
Wow.
Tons of potential information, but you can't really get to it easily. You can't change it easily.
Okay. So a rock is like a really boring library.
Kind of, yeah.
Water, on the other hand, it's like always moving and shifting and, changing states, dissolving stuff. So does that mean like water actually has more information density than a rock?
I think you're really picking up on something there.
Okay.
Water, even though it's less dense, if we're just talking about mass per volume, it really is like a star when it comes to information density.
Wow.
And the key is the key is in its molecular structure. You got these hydrogen bonds; they're constantly forming and breaking,
Right.
and that creates this really flexible network that's always shifting. It's like a library where the books are constantly rearranging themselves.
Okay.
Super efficient.
So water's like a super organized, self-updating library.
Yeah, that's a great way to put it.
I got to say, though, you said something earlier that kind of blew my mind a little bit.
Oh yeah.
You were talking about mass itself.
Mm.
Like the fact that something has mass, maybe that's a form of information density.
Yeah. It's a really wild idea. So the source we looked at, it basically suggests that mass itself, like the very essence of it, the stuff that makes everything up, could be like this manifestation of information density. Like, what if the whole universe is like a giant computer
Okay.
and mass is just a way of encoding information?
Wow.
Right.
That's a lot to think about.
Yeah.
So like even our boring old rock, just because it has mass,
Yeah.
it has some level of information density, but like it's not good at using it or like expressing it.
Exactly.
Like imagine a book written in a language that nobody can understand.
Yeah, that's a perfect analogy. And then water with its, constantly changing interactions.
Right.
It's like a book that's always being rewritten, always being updated.
Yep.
So that information is way more accessible and adaptable.
Okay. So it's not just about how much stuff is crammed in, it's about how flexible it is
Yeah,
and how much potential for change it has.
exactly.
And this brings us to black holes, right? Because black holes are like the kings of density, right?
Yeah, the ultimate.
But what about information density? Are they the biggest information hoarders in the universe?
Black holes are, well, they're fascinating because they kind of take information density to a whole other level. You're talking about taking all the mass and energy of a giant star and squeezing it into a space smaller than an atom.
Wow.
And that's a level of information density that actually warps the fabric of space-time.
Wait, are we saying like information can be so dense that it literally like bends reality?
It might sound like, I don't know, science fiction.
Yeah.
But it's actually what Einstein's theory of general relativity describes. And here's where it gets like even more mind-bending. Some physicists think that black holes might be the most efficient information storage systems in the entire universe.
Really?
Yeah, holding like unimaginable amounts of information in their, mysterious depths.
So black holes are like what, the ultimate cosmic libraries?
It's a possibility, and it leads to some really deep questions. Like, if information is actually preserved inside a black hole, what happens to it?
Right.
Could we ever get to it? And, even bigger, what does it tell us about information itself?
Okay. We've gone from rocks to water to black holes. And I think my brain might be full. But before we go too far down the black hole rabbit hole, let's bring it back to something a little closer to home. Life. We all know water is like essential for life,
Right.
but how does its crazy information density actually make life possible?
It's a great question, and it's where we really see this information density thing playing out on a level that we can actually grasp. Water's ability to store, transmit, and change information, it's not just some cool fact.
Yeah.
It's the foundation for, like, all of biology. And what's really wild is water's information density, it's not just about how much, it's about how it's used, how it adapts. Like, life needs this balance between stability and change.
Okay.
And water, with those hydrogen bonds, it can do both.
Right, right. Okay, so I get the change part,
Right.
but how does it create stability?
Think about water's heat capacity.
Oh, okay.
It can absorb tons of energy without, like, going crazy with temperature swings.
Yeah.
So it keeps things nice and stable for those, delicate biological processes.
So water's like a buffer.
Yeah.
Keeps everything from like getting too hot or too cold.
Exactly.
Like a global thermostat.
Yeah, like that.
But we talk about how water dissolves things, right?
Right.
How does that play into information density?
Dissolving, it's not just about breaking things apart. It's about creating new connections, new pathways for information to, like, flow.
Okay.
Those dissolved substances, they can react, they can combine, they can build complex structures, and water is like the facilitator.
So the more stuff water dissolves, the more possibilities there are for like complex information processing.
Yeah, exactly.
It's like a recipe.
Uh-huh.
Water's the main ingredient, and it like brings out all the flavors of everything else.
Yeah, I like that. And this whole idea of complexity, it gets even more interesting when you think about water's ability to facilitate quantum effects.
Wait, hold on. Quantum effects.
Yeah.
Like subatomic particles and stuff.
Yeah, so there's more and more evidence that quantum stuff, things like coherence and entanglement, could be happening in, living things.
Yeah.
And water, with its unique structure, it might be the reason why.
Okay.
Like, it creates the perfect environment for those effects to happen.
So water is like, what, a quantum playground for life?
Kind of, yeah.
But how does that connect to information density?
Well, imagine these quantum effects as, like, tools to manipulate and process information, but at incredibly tiny scales.
Okay.
And water, it makes those tools work. So essentially, it's enabling a whole other level of information density inside living organisms.
Whoa, okay. So water's not just sitting there, it's actually like shaping the information landscape of life.
Exactly.
This makes me wonder, though, can this connection go even deeper?
I think you're onto something. Remember we were talking about mass itself maybe being a form of information density?
Right.
And our brains, they're mostly water and fat. And those are, high information density substances.
Are you suggesting that water could be connected to, like, consciousness?
It's definitely a bold idea. And it's, still out there. But if you consider that the information density of water and fat in our brains might be why we can think, well, it opens up some possibilities.
So water, this like simple thing we all know,
Right.
it could be one of the keys to understanding the biggest mystery, consciousness. We've gone from rocks to water to our brains and now to consciousness. This deep dive is quite a trip.
It is, isn't it?
Yeah.
And that's what's so great about thinking about these big ideas. They make you question what you thought you knew. They lead to, like, deeper questions.
Yeah.
But speaking of big ideas, let's go back to those cosmic giants we were talking about earlier.
Black holes.
Yeah, black holes. They're like the ultimate example of information density pushed to the limit. They really push the boundaries of what we thought was possible.
Okay.
Yeah.
I'm ready for round 2. Tell me about black holes and information density. Okay, so black holes.
Huh.
We've talked about, how crazy dense they are,
Yeah.
like squishing a whole star into a space smaller than an atom. But how does that actually connect to information density?
That's where things get really interesting. Because remember, information density, it's not just about how much information you can, like, cram in there.
Right.
It's about how it's organized. How easy is it to actually, like, get to that information,
Yeah.
And black holes, they seem to take this to, like, the ultimate extreme.
Okay. I'm trying to picture it, but it's hard. Like, we talked about water, right?
Right.
And how its structure makes the information inside dynamic
Right.
and usable.
Hmm.
But what's going on inside a black hole that makes it, I don't know, such a good information storage system?
It's really hard to say for sure because To be honest, the conditions inside a black hole are so wild that our current physics, they kind of break down.
Yeah, yeah, it's like the rules don't apply anymore.
Exactly. But one theory, one of the leading theories is called the holographic principle.
Okay.
And it suggests that all the information that falls into a black hole, it doesn't just disappear. It
Yeah.
gets encoded on its event horizon.
The event horizon. Okay. That's the point of no return, right?
Right.
Like the cosmic boundary, nothing escapes.
Exactly. Not even light.
Right.
And the holographic principle, what it says is that instead of just being lost forever, all the information about everything that goes into the black hole, it's saved on this like two-dimensional surface,
Okay.
like a cosmic hologram.
So like projecting a 3D image
Yeah.
onto a flat surface,
Yeah.
that's wild. But like, how can something as complex as a star, with all its energy and particles and everything, be reduced to information on a flat surface?
That's the mind-blowing part. It suggests that information, like the very concept of information, might be way more fundamental than we realize.
Okay.
It makes you question, like, what is reality? You know?
It really does. Okay, so think about it. We started with rocks,
Yeah.
right?
Mm-hmm.
Low information density. The structure is so rigid, so fixed.
Yeah.
Then we moved to water. More information density. It's always changing, always adapting.
Right.
And now we're talking about black holes. And they seem to, like, rewrite the rules completely, encoding information about whole stars on their event horizons.
And if the holographic principle is right, it means that information might be like indestructible, even with, the most powerful forces in the universe trying to destroy it.
Wow. That's a pretty profound thought.
Yeah, it really is.
Okay, so from simple rocks to mind-blowing black holes, we've seen how information density, it's not just some scientific concept, it's like woven into the fabric of reality.
Right.
It shapes everything from tiny particles to giant structures in the universe.
And what's amazing is we're just scratching the surface. There's still so much to learn, so many questions to ask about information density.
Well, that's the beauty of science, right? It's
Yeah.
about always pushing the boundaries, always asking those questions. So keep those minds curious, folks, and we'll catch you on our next deep dive.